Today we will discuss about inverting rectifier. In previous class, uh, we go through non-inverting rectifier. So today we will discuss about inverting rectifier. So here is the circuit. So we will discuss it in two cases. So the first case, in this case, the circuit is like previous one. It is our non-inverting rectifier. So in first case, the circuit is like non-inverting rectifier, but the difference is there. The diode is connected in reverse than the previous one. So here is the V input. This is our V output, and here is our Vx. Okay. So for first half cycle of input voltage, this is our first half cycle. So in this case, V input is greater than 0. That means that means V positive, V plus is greater than 0, and initially V negative is 0. So what will happen for Vx? Vx is uh, open loop gain, uh, and the voltage difference of the non-inverting and inverting input, and the multiplication of these two is the Vx. So the Vx will be a open loop gain V positive minus V negative, and this is obviously will be plus infinite. Okay, plus infinite. So if the Vx is plus infinite, then obviously diode will be off. Diode is off or open. Why diode is open? Because in that in this case, the n side, this is n side, this is p side. So n side should be negative or less than p side. But here Vx is connected with n side, and Vx is plus infinite. That so in this case, obviously the diode will be open. So if the diode is open, then obviously this circuit will not be happen to contact. For this reason, V output is 0. V output is 0. For negative portion of the of one cycle, V input is less than 0. If V input is less than 0, then V plus is less than 0, and V minus is 0 as initially it is taken. So now Vx will be infinite multiplied by V positive minus V negative. So as it is less than 0 and it is 0, so the multiplication is minus infinite. Okay. So if n side is minus infinite voltage, and p side is as initially it is grounded with resistance R, then obviously the diode will be on. If diode is on, then circuit is fully in operation. So in that case, V output will be equal to V in. So now V output is like V in. Okay, this is our first case. But our intention is to make the voltage, to make this voltage to this level. Okay, so our intention is to make this negative voltage to the positive rectified voltage. So for this reason, we have another modified circuit. So here is our modified circuit. This is our modified circuit for second cases, for second case. So in that case, so V in, now for one cycle V in is positive and another portion is negative. So for positive portion, V in is greater than 0. If V in is greater than 0, then current will try to contact to so D1 will be on. Why on? Because current will go through R1 and this direction. And V in is greater than 0, then obviously the voltage at in this side will be greater than 0. So D1 is on. So D1 is on. Okay. So what will happen for D2? Okay, so for that case, we need to find out the Vx value. So we see that here Vx will be open loop gain is always infinite for ideal diode. For ideal diode, it is always infinite. So we have to now see what is the difference between V plus and V minus. V plus is grounded, so 0, and V minus is connected with R1 uh, through R1 with V input. That's why there is a possibility that V negative always will be for positive half cycle. It will be positive. So if V plus, so infinite multiplied by 0 minus positive something value, what will happen? Vx will be minus infinite. Okay, minus infinite. If Vx is minus infinite, then D2 will be off. D2 will be off. If D2 is off, then the circuit is not in operation. Okay, the circuit is not in operation. So for positive half cycle, the output will be 0. There is no output. Okay, so for negative half cycle, V input is less than 0, and we assume that there is a voltage V minus. V minus is also less than 0. Okay, and V positive is 0. So for Vx, it will be infinite multiplied by 0 minus 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 into minus sign. That will be positive voltage. If Vx is positive voltage, then D2 will be on. So D2 is on. Okay. As V input is negative half cycle, so D1 will be off. So D1 will off. D1 will off. Okay. So D1 is off. In that case, the current will flow R1 via R1, R2, and and the output voltage will be V output. So if R2 is equal to R1, then V output will be minus R1 by R1 V input. That means minus V input. So as V input is negative, the V output will be positive. Okay. So it was our inverting rectifier by op-amp, precision rectifier by op-amp. So there are two cases. So in first case, our output comes in negative portion, and in second cases, and in second case, our output voltage is become positive though the input is negative. Okay, so that is our inverting precision rectifier circuits. So so the last part is full wave rectifier. Full wave rectifier is not so much difficult. So it's mainly the combination of non-inverting plus inverting rectifier. The combination of both is the output of full wave rectifier. So here is our non-inverting rectifier, and this is our inverting rectifier. Okay. So how do we happen? So for positive half cycles, for a positive half cycle, output voltage will be positive, and this is obviously non-inverting. And for negative half cycle, the output voltage also will be positive. For which one? For inverting rectifier. For inverting rectifier. So this is the result of full wave rectifier by op-amp. Okay, so it is not so much difficult to find out the output. Rather than we need to understand these two circuits for inverting rectifier. So thank you everyone to connect with me.